see something cool?
What is up, y'all? My name is Rhino Spartan, and I have finally returned to Space Engineers to present to y'all my fourth iteration of my Clang Drive design. For those who don't know, a Clang Drive is a device that utilizes the broken physics in Space Engineers to propel an object in a certain direction. Before I explain how this contraption works, I first want to explain the history and what led to the construction of this device. Well over a year ago, I discovered that the override feature on gyroscopes allowed for a significant reduction of rotation in certain grids. I applied this concept and created both a motorcycle as well as a unicycle. Following the creation of these vehicles, I then had the idea of applying the concept to the Clang Drive. This device got its name from the clang-like sound that is heard when it is activated. For those who haven't heard, this is the sound. The gyroscopes act as a form of stabilization because an equal amount of override is exerted on four sides of the Clang Drive, hence the name Stabilized Clang Drive or Contained Clang Drive. After making this device, I decided to make a more powerful and faster version. This of course led to the construction of my second Clang Drive. This version exerted 9 times the amount of power of the first and was substantially more maneuverable as well. Both of these contraptions operated off of the same basic system. An airtight hangar door would be placed onto a rotor, a separate grid, and when it would be activated, it would push on the top part of the device, pushing the whole thing in whichever direction. While these two contraptions were extremely effective, they still cost a more than ideal amount of resources and also took about 3 seconds to activate. To resolve these two main issues, I chose to use a different core system similar to one suggested by a few of my viewers, and I built my third iteration. The third version reduced the amount of resources required and also activated nearly instantly. Rather than using an airtight hangar door for propulsion, it used a smaller door and a symbol attached to a piston, which is also a separate grid. When activated, the small symbol on a separate grid than the door would push the door while also trying to get unstuck and propel the device. The piston is extremely close to the door, allowing for a near instantaneous activation. That's not coming back down, is it?
Bye!
Even though this iteration was extremely cost-effective and used a more stable system, it didn't have the same amount of power as the previous two. So I took the designs of all three, analyzed their best attributes, and combined them into one contraption. That contraption is, of course, my fourth Clang Drive. The core propulsion system for this iteration is a combination of the two previous systems. A symbol, or in this case, an exclamation mark, placed on a piston pushes into the airtight hangar door when activated and exerts force on the entire contraption. This mechanism behaves more like the system of the third version, with the only differences being a hangar door is used instead of a small door and an exclamation mark is used instead of a hyphen. I opted for a hangar door instead of a small one because the part that hits the cymbal has more surface area than the small door and thus exerts more force. That's my hypothesis. Much of this makes little logical sense. The first system exerts the most force, and the third system is the most stable and safe to use. The fourth is the one that balances these two attributes. To show this, I have placed weights equivalent to 540 metric tons on each system type. As you can see, the fourth iteration is in second place when it comes to force, but is still somewhat comparable to the first. If you are looking to conserve time as well as resources, then this contraption would be ideal for you to use. This contraption can greatly minimize the amount of hydrogen and power you need to collect in order to travel, and also reduce the amount of time collecting said resources. Since this version is relatively more complex than the previous three, I'm going to provide a tutorial on how to build it. Before I do that, here is the list of parts you will need to build the Clang Drive and the approximate number of each part required. You can take a screenshot of this for reference if needed. You first need to place a 1x1x1 block for support either on a station or in some terrain. It can be any block because it will be removed when you finish. I am going to use beam blocks for all example supports in this tutorial. After placing your first support, you will place a rotor on top of it with the rotor head facing away from the support. You then place two batteries, with one placed on the right side of the rotor and one placed on the left. Next, you place two merge blocks on the remaining horizontal sides of the rotor, with the connector faces facing down. Once you placed the merged blocks and batteries, you then want to place 4 gyroscopes on top of both the merge blocks and both batteries, having the faces with the control panel facing away from the rotor. You then activate the rotor's inertia tensor, set its displacement to -32 centimeters, and lock it. You can now place the hangar door on top of the rotor with the metal details facing the merge blocks. After placing the hangar door, you can now create the structure itself. Follow the block placement displayed on your screen. Now that you have built the structure of the bottom half of the device, you now have to do something quite precise. You're going to close the hangar door, then quickly turn it off once it has extended 3/4 of a block. You can more easily do this by switching the hangar door to closed and turning it on and off repeatedly until it has extended that far. You can use a half armor block as an indicator. Now that you have extended the hangar door 3/4 of a block, you can now activate and set up the gyroscopes. Firstly, you are going to select all 4 gyroscopes on the Clang Drive and create a block group that includes them exclusively. To more easily identify the block group, you can name the group Override Gyroscopes. If you grouped the gyroscopes correctly, you can now set up the override. You're going to want to select the pitch override bar and set it at 2 RPM. After finishing the bottom half of the contraption, you can now create the top half. You will create a structural support that is 9 blocks tall on the same block level as the support, holding the bottom half. Next, you will place a support onto the 8th support block and delete the top support block. You can now create the structure of the top half by copying the block placement shown here. After placing these 8 armor blocks, you will now place a piston into the center opening with the piston head facing down. Once you've placed the piston, you will now place an exclamation mark onto the piston head with the dot facing to either the right or left of the support pillar. You will then activate the piston's inertia tensor, set the minimum distance to 0.2 meters, the maximum distance to 0.7 meters, and set the velocity to minus 3.0 meters per second. You can now place half-slope inverted light armor blocks in the rotation and location shown on your screen. You can now combine the two halves through the use of merge blocks. This only requires a merge block for the top half and one for the bottom half. You will place 2 supports on the sides of the 2 halves as shown on your screen to support the merge blocks. You can now place a merge block on each support with the connector faces facing towards each other. Next, you're going to want to remove the support holding the top half so that the top half can attach to the bottom half. Once the merge blocks indicators have turned green, you can remove the supports holding them up, as well as all other supports. If you followed all these steps correctly, you will have a fully functional contained Clang Drive version 4 ready to be put to use. If you would like to have the blueprint readily available to you, the workshop link is down in the description. If you have any questions or suggestions, please leave a comment down below. Y'all's feedback is greatly appreciated. And if you found this video helpful and or enjoyable, please leave a like and subscribe. Thanks y'all so much for watching. I hope you have a great day. Goodbye.